Welcome pre-calc students to lesson 5.3. Today we're going to talk about inverse variation as the nth power. The definition here says let x and y denote two quantities and n be a positive number. Then y is inversely proportional to the nth power of x, or y varies inversely as the nth power of x. If there exists a non-zero case such that y is equal to k divided by x to the nth. Now, if n is 1, then it's just y equals k divided by x to the first. Then y is inversely proportional to x. One way of looking at this is as x goes up, y will go down. Or as y goes up, x goes down. They're inversely proportional to one another. So, moving on to the next slide, we have modeling the intensity of light. Here it says the intensity of light I is inversely proportional to the second power of the distance d, meaning the farther you move away, the less intense the light is. So the equation I equals k divided by d squared models this phenomenon. At a distance d of 3 meters, says a 100-watt bulb produces an intensity of 0.88 watts per square meter. So this is I, my intensity right there. So what I want to do is I want to find the constant of variation k. In order to do that, I'm just going to substitute 0.88 in for I, and I'm looking to find out what k is. My distance is 3. So k in this problem is going to end up being 9 times 0.88, which I believe k is 7.92, I believe. All right. So my formula now has turned into I equals 7.92 divided by d to the second power. And they want to find the intensity of the light at a distance of 2 meters. So my intensity should be higher. So now this is going to be I equals 7.92 divided by 2 to the second power. That's going to be 4. My intensity is going to be close to 2. If I take 7.92 divided by 2, I'll do that right now on my calculator. And actually it's 7.92 divided by 4. My intensity has now come up to 1.98. Now the farther you move away, the less intense that light is going to be from that 100-watt bulb. So that is a really nice example of inverse proportion. All right, joint variation. This time it says let m and n be real numbers, then z varies jointly as the nth power of x and the nth power of y if there is some non-zero real number k that exists. So joint variation is everything is direct variation. And we talked about direct variation earlier in the year. That was where y was equal to k times x. Well, now we've got more than one variable and we've got a higher power. We could have direct variation with x squared as well. Okay, so if we've got more than a couple unknowns here, in this case we've got an unknown y and an unknown x, then we've got x and y and z. Okay, so moving on, modeling the amount of wood in a tree. It says the volume V of a tree varies jointly with the 1.12 power of its height h and the 1.98 power of its diameter d. So what that means is V is going to be equal to K times H raised to the 1.12 power times D raised to the 1.98 power. So that's going to be my answer for part A. Part B, I'm going to want to substitute 13.8 in for D. So I'm going to add a page here. I'm going to have 13.8 raised to the 1.98 power. I'm going to go back. My height was 64, so I'm going to substitute 64 in for h, and that's going to be to the 1.12 power. That's times k, and that's equal to the volume in this wood was 25.14 cubic feet. So now, in order to solve for k this time, I'm going to have to divide by 64 to the 1.12 power. I'm going to get 25.14 divided by 64 to the 1.12 power. times 13.8 divided by the 1.98 power. When you find that value of K, I had a sheet of paper with the answer on it, so I'm going to have to do it on my calculator. 25.14 divided by, I'm going to use parentheses, 64 raised to the 1.12 power times 13.8 raised to the 1.98 power. And I hit enter and I get K is equal to 0.00132. So that's my constant of variation. So now my equation, my volume equation, has turned into 0.00132 times h to the second, or excuse me, h to the 1.12 power times d to the 1.98 power. So in the next example, they say estimate when the diameter is 11 and the height is 47. I'll slide that up. So now I'm going to substitute 11 in for d. I'm going to have 11 to the 1.98 power, and I'm going to have 47 to the 1.12 power, and I'm going to take that 0.00132 times those values, so I'm going to type that into my calculator. So I got 0.00132 times 47 raised to the 1.12 power times 11 raised to the 1.98 power, and my volume of wood in that one would be 11.4 units, cubic units. Okay? All right. Last but not least, we have combined variation. This is where we combine direct and inverse. So right here it says the strength S of a regular or rectangular beam varies directly with its width W and the square of its thickness T. So right now I know that S is going to be equal to K times W times the square of its thickness T. All right, now I'll change colors here. It says a beam that is excuse me, and then it says and what? And inversely with its length L. So that means I got to divide by L. All right, so now it's just going to substitute in for variables. So I got to pick out the value of T right there. T is 4. Oh no, 4 is W. W is 4. It's 4 inches wide. It's 10 inches thick, so that's T. And then it's 120 inches long. And the load that it can support, S, is 1250. So I'm looking at 1250 equals K times 4 times 10 to the second divided by 120. The L was 120. So I'm going to get 400 divided by 120. So I'm going to add a page here, go to the next page. I'm going to get 1250 equals 400K divided by 120. We'd want to times both sides by 120. And then we would want to divide by 400. So we're going to get K equals 120 times 1250 divided by 400. I can calculate that real quickly. 120 times 1250 divided by 400 is 375. So K comes out to be 375. So now my formula on the other page is V equals K times, K is 375 times W times T squared divided by L. And now they want me to determine how much a similar beam that is 3 inches wide, so W is 3, T is 12, and the length is 100. So we'll see if I can remember all that. So we got 3, we got 12, and we got 100. So now it's just plug and chug, and we can do that calculation. So it's going to be 375 divided by 100 is 3.75 times 3 times 12 to the second power. This support, and this is actually S, the amount it can support is 1,620 pounds. All right, everybody, that is lesson 5.3, part B. Thank you for listening.